The rest of section 6.6 is solving the logarithmic equations. So I split the section into two parts. The first part was solving exponential equations. Each of the problems in part 1 of this video was an x, and it was tucked inside, was part of an exponent. The rest of the problems in this section are going to have logarithms. They're called logarithmic equations, and for most of the problems, except for a couple, we're going to get rid of the logarithms by using the rule that we had that said if the log base b of x equals to y, then b to the y power equals x. So we spent a decent amount of time and did a decent number of problems in one section, I forget if it was 6.5 or 6.4, I think it was 6.4, of taking a problem that had a logarithm and an equal sign and writing it without a logarithm. That's what I'm going to do to get started in problem 26. And just in case you forgot, in problem 26, the 2 is the b, the x is the x, which is kind of nice, fortunately, and the 3 is in the y position. What I'm going to do is take this problem and write it without the logarithm. I'm going to write an exponential equation. The b is going to be the first thing on the left-hand side, which is the 2. The y is going to be the exponent, which is the 3. The equal sign is going to stay here. The x, which is an x, is going to go to the right of the equal sign. So I'm using this formula to rewrite the problem without a logarithm. And now it just gives me the answer because 2 cubed is 8. So I'm going to get 8 equals to x. I claim that's my answer for problem 26, but I should certainly check, and it's real easy to check. To check this, it should be the case that if I plug in 8 in for x and go the log base 2 of 8, that should equal to 3. It does say round to 2 decimals, but I don't see any decimals here. I'm going to put my calculator in mode float until I get to a problem that has an ugly decimal. So back to mode float. When I go to check this, I'm just going to use the change of base formula and do log of 8 divided by log of 2 on my calculator. If it gives me 3, which it did, I know that my answer is correct because the original problem had a 3 on the right-hand side, and when I put my answer into the left-hand side, it matches up both sides, so my answer is correct. Oh, no, I don't think I needed. Thought immediately I was going to need a 2 decimal answer, but that's not the case here. So for both problems 27 and 28, I want to rewrite the problem without a logarithm. Both of them are written in shorthand because ln is the same as log base e. And what I'm going to need to do before I can rewrite the left-hand side so it doesn't have a logarithm is I need to make the ln log base e. I can use the formula to rewrite the problems without a logarithm, or I could use the shortcut technique. The shortcut technique is what we did mostly. So my second step after I get the problem written without the shorthand ln with the log base e, I'm going to cross out the log and I'm going to leave the e on the left-hand side, the equal sign on the right-hand side. I'm attempting to write a problem without a log that has the same answer as a logarithmic equation. I'm going to move the x to the right-hand side. It's going to be on the same level as the e. The 0 is going to move to the left-hand side, and it becomes the exponent. So I get e to the 0 equal to x. My answer is going to be 1 because anything to the 0 power is 1. When I go to check this, so there's my answer for 28. When I go to check, I'm going to go, is the ln of 1 equal to 0? And that's going to be super easy to do because I just type ln and 1. My calculator forces a parentheses on me, and I'll get 0 equal to 0 just fine. For your problem 27, let me see if I could just sneak it in just because it's a little bit different. So for your problem 27, I would start off writing the left-hand side is the log base e of x equals to 1. I'm going to cross out the log. I'm going to leave the e on the left-hand side. I'm going to leave the equal sign where it's at. The x is going to move to the right-hand side and be on the same level as the e. The 1's going to move to the left-hand side and become an exponent. Your answer is completely probably best written as x equal to e. I don't need to make that into a decimal. That's better than a decimal. When I go to check yours, I'm just going to check by seeing that the ln of e is equal to 1. And that's a common fact, that the log base e of e or the ln of e is 1. But let me check that real quickly by going ln and then second and the divide key to get the e, close out my parentheses, and your problem 27 would reduce to 1 equals to 1. The next few problems have a parenthetical comment, and this parenthetical comment in this question says, so we're solving the question, the log base x of 49 equal to 2, and the x greater than or equal to 0 says that if your solution comes up with a negative number, that we can't include it. We're only going to include positive solutions. I don't think that's going to be an issue so much, but we only want positive answers, and if our solution would generate a positive and a negative, logarithm bases can only be positive numbers. We'll only accept the positive solution. So let me do problem 30 and then talk you through problem 29. So I'm going to rewrite problem 30 so it doesn't have the log. I'm going to cross out the log. The x is going to stay on the left-hand side. The equal sign is going to stay between. The 27 is going to move to the right-hand side. The 3 is going to move to the left-hand side and become an exponent. So I have x cubed equal to 27. The way to get rid of a cube to solve for x is to cube root both sides. So to get the x solved for, I'm going to cube root both sides. On the left-hand side, cube root symbols cancel out cubes, and it makes it so I just have the x. On the right-hand side, I have the cube root of 27. If you don't know that, you just hit your math key, go down to option 4 that says cube root, type in the 27, and it will tell me that the cube root of 27 is 3. So I claim that that's my answer to problem 30. To check it, it should be the case that the log base 3 of 27 equals to 3, just changing that x to 3. And to check it, I would just do log of 27 divided by log of 3, and I'll get 3 equal to 3. For your problem 29, when you get started, you'll cross out the log, you'll leave the x on the left-hand side, you'll leave the equal sign where it's at, the 49 is going to move to the right-hand side, the 2 is going to move to the left-hand side and become an exponent. You'll get x squared equal to 49. And to get rid of a square, you square root. Generally, you plus or minus square root, but this only wants positive answers, so I'll just positive square root. And then I'll, on the left-hand side, square roots cancel out squares, leave me with an x. On the right-hand side, I know the square root of 49 is 7. That's going to be the answer to problem 29, and I won't check that, but you can definitely check that. Your problem 31 is a lot like my problem 30. I'm going to jump into 32. For 32, I'm going to cross out the log. I'm going to leave the x on the left-hand side. I'm going to leave the equal sign where it's at. I'm going to move the 32 to the right-hand side, leave it on the same level as the x. Move the 5 to the left-hand side and make it an exponent. To solve an x to the 5th, to get rid of that exponent of 5, I need to 5th root both sides. So I'm going to 5th root the x to the 5th and 5th root the 32. 5th rooting an x to the 5th. The 5th root and the 5th cancel each other out, leave me with an x. The right-hand side is the 5th root of 32, which I know to be 2, but on my calculator it's tricky. To do the right-hand side, if you didn't know the 5th root of 32, you type the number 5 for 5th root, you hit the math key, and go down to option 5. And what my calculator is going to do is it's going to think of that x as a 5, and now I'll type the 32 in, and I'll get the 5th root of 32 as 2. Your problem 31 won't have that because it's going to have a cube root, which your calculator can do just fine. For my checking in problem 32, I should make that x into a 2 and see if the log base 2 of 32 equals to 5. On the left-hand side, I'm just going to go log of 32 divided by log of 2. And the left-hand side is going to give me a 5 equal to 5. So I won't do your 31. It should solve similarly. (33) and 34, same style. 33, I'm going to cross out the logarithm. This parenthetical comment doesn't impact the algebra other than I can only have positive solutions. When I cross out the logarithm, I'm going to leave the x on the left-hand side. I'm going to leave the equal sign in place. I'm going to move the 4 to the right-hand side, make it on the same level as the x, move the 1/3 over and make it an exponent. Now I'm going to rewrite the left-hand side as a radical. Fraction exponents turn into radicals, so I'm going to write a radical sign for the left-hand side. The denominator of the fraction becomes the index, and everything else goes under the radical. So x to the 1/3 power is the cube root of x to the first, and that's just the cube root of x equals to 4. To get rid of a cube root, you cube. So I'm going to cube both sides. On the left-hand side, cubing cancels out a cube root, leaves me with just an x. And on the right-hand side, 4 cubed is 64. That's supposed to be my answer to problem 34. When I go to check it, it's a little bit tricky because the right-hand side's a fraction. When I go to check it, I'm going to get an ugly answer for a second that I'll have to math enter to make it into that fraction. So I'm going to plug a 64 in for the x and see if the log base 64 of 4 equals to 1/3. On my calculator for the left-hand side, I'm going to go log of 4 divided by the log of 64. I'm not going to get a fraction, I'm going to get a decimal, and then I'm going to math enter, and it works perfectly that both sides come out to be 1/3. All right, 35 and 36, I'm going to do the same thing. I'm going to get rid of the logarithms by crossing out the log. On 36, the 3 is going to stay on the left-hand side. The equal sign is going to stay where it's at. The x minus 5 is going to move to the right-hand side. And when it's free of the logarithm, it doesn't really need to be in the parentheses anymore. The 2, I'm going to move to the left-hand side and make it an exponent. On the left-hand side, that 3 squared is equal to 9. So this gives me 9 equal to x minus 5. And then I'm going to add 5 to both sides. And for my answer, I'm going to get 14 equal to x. I should check, because it's so quick to check. To check, I'm just going to plug 14 in for that. I'll get the log base 3 of 14 minus 5 equals to 2. So I'm going to do that on my calculator. On my calculator for that, I'll do the log parentheses of 14 minus 5 and then divided by the log of 3. And because it gives me 2, I know my answer is correct. So up to 38, all the problems are more or less the same. And then once we get beyond 38, we'll get in rapid succession 3 different kinds of problems. For 38, I'm going to cross out my log. I'm going to write 3 on the left-hand side, keep the equals between them. I'm going to move the 3x over. It won't need to be in a parentheses anymore. I'm going to move the 0 over and make it an exponent and get 3 to the 0 equal to 3x. Anything to the 0 power is 1, so I'll get 1 equal to 3x. I'll divide both sides by 3 and get 1/3 equal to x for my answer for 38. Easy enough to check, so I'll check it. To check it, it should be the case that the log base 3 of 3 times 1/3 equals to 0. I think I can enter that just like that, just plugging 1/3 in for that x. So I'm going to go the log of 3 times 1 divided by 3 for the logarithm of the argument, divided by the log of the base, which is the log of 3. And when I hit enter, it better give me 0, otherwise my answer is not right. So up through 38, there is only one logarithm. It's on the left-hand side. there's a number that without a log on the right-hand side. Doing the strategy that we did is really the best and only way to solve these. (39, 40, and beyond), each of the problems is going to solve a little bit differently. Well, there's a couple of groups, and there's 3 kinds of problems. The next 4 problems, 39, 40, 41, and 42, are unique, and they're different than the other problems that we've just done because they have one logarithm on each side of the equal sign, and the logarithms are the same base. In 39, both your logs are base 10, and 40, both my logs are base e, and 41, both the logs are base 2, and in 42, both the logs are base 4. For each one of these 4 problems, because there's a logarithm on each side of the equation, there isn't a number that's not part of the logarithm. I can simply just drop the logs and set the arguments equal to each other. So these are special problems where I can just drop the logs without any switching. And all the other problems that we've done in this part of the video so far, on the right-hand side there wasn't a log, and when you drop the log that way you have to switch. But when I go to do problem 40, I can just drop the log and go x minus 4 equals 2x minus 10, and then I just need to do the algebra to get the x's on one side, the letters on the other. I'm going to start off by minusing x from both sides. That's really minusing 1x. That's going to give me minus 4 equals x minus 10, because 2x minus 1x is 1x. And then I'm going to add 10 to both sides and get 6 equals to x. I claim that's my answer to problem 40, and I'm going to check it. On the left-hand side, I'm going to go, is the ln of 6 minus 4, now on the right-hand side, equal to the ln of 2 times 6 minus 10. Let me do both on my calculator. So left-hand side, ln of 6 minus 4 gives me that horrible decimal. And on the right-hand side, ln of 2 times 6 minus 10 gives me that same number. So I know my answer is right because both sides come out to the same number when I evaluate each of the sides for my answer. So this strategy is just plain out dropping the logs only is applicable when both sides have a logarithm and there's no stray number that's not part of an argument of a logarithm, and the logarithms are the same base. So 39, 40, and then 41 and 42 will all solve the same way. When I go to do 42, I'm going to drop the logs because on either side of the equal sign I have logarithms and nothing outside the logarithms, and the bases are the same. To get 42 solved, I'm going to minus 3x from both sides, and that's going to give me 6 equal to x. Your answer for 41 is going to be a fraction. When I go to check this, on the left-hand side it has to be the log base 4 of 3 times 6 plus 6, and on the right-hand side it's going to be equals the log base 4 of 4 times 6. Let me do both sides on my calculator to make sure they work. So the left-hand side, I'm going to do the log of 3 times 6 plus 6 divided by the log of 4. Gives me that horrible decimal. And on the right-hand side, I'm going to do the log of 4 times 6 divided by the log of 4. Gives me that same horrible decimal, so I know my answer is correct. So those 4 problems are going to be completely different than all of the logarithm problems that we solve. They're the only time you can just drop the logarithms is when you have 2 logarithms on either side of an equal sign and they're the same base. The next few problems have 2 logarithms, but they're on the same side of the equal sign and they solve a little bit differently. So 43, 44, 45, 46, and 47 all have 2 logarithms separated by a minus sign. They're on the same side of the equation and they're going to be tricky. I'm going to do problem 44 by rewriting the left-hand side with 1 log. So to get started on your problem 43 and my problem 44, I need to rewrite the left-hand side. And I've already used this rule when I did the problems in part 1 of this video, where we had the exponents on both sides of the equal sign. To rewrite a logarithm that has 2 logarithms, same base, separated by a minus sign, you can make the 2 logarithms into 1 logarithm by dividing the arguments. So I'm using the kind of the minus to divide rule, the second of the logarithm rules that I wrote down in section 6.4, I think it was. Now that I have each side, the problem written so with only 1 log, now I'm going to go to the cross out mode. So I'm going to cross out the log. I'm going to leave the 3 on the left side. I'm going to leave the equal sign where it's at. I'm going to move this ugly fraction over to the right hand side and make it on the same level as the 3. I'm going to move the negative 1 to the left hand side and make it an exponent. 3 to the negative 1 power is equal to 1/3. If I did that on my calculator, 3 up arrow negative 1 and did math, enter, enter, I get 1/3. 3 to the negative 1 power is the same as 1 over 3 to the first power, which is 1/3. This problem is set up perfectly to solve by cross multiplying, because now I have 1 fraction on either side of the equal sign. So I'm going to cross multiply both directions. Cross multiplying down. Cross multiplying up, I get 3 times x. Cross multiplying down, I get 1 times x plus 6. This gives me 3x equals, I'll say 1x plus 6. I'm now going to minus 1x from both sides. That's going to give me 2x equal to 6. And then I'm going to divide both sides by 2. And when I have my answer, I claim that my answer to problem 44 is x equal to 3. I should certainly check it. And for checking, it has to be the log base 3 of 3, that 3 is going to need to be in a parentheses, minus the log base 3 of 3 plus 6 has to equal negative 1. So I'm going to enter all this on my calculator by going log of 3 divided by 3, the log of, I'm going to make this 9 divided by 3, log of 9 divided by log of 3. Make sure that that equals to negative 1. So on my calculator, to check this, I'm going to go log of 3 divided by log of 3 for the first log, and then this minus sign. And I did that 3 plus 6 in my head to make this easier to enter. For that logarithm, I'm going to do log of 9 divided by log of 3. When I hit enter, it better give me negative 1, because the right-hand side's already negative 1. There's nothing else I can do to simplify that right-hand side. And it does, so I know my answer is perfect. So your 43 is going to work the same way. I should probably do your 45 as opposed to my 46, because my 46 is actually a little bit easier with this negative exponent. Maybe I'll do 45, and maybe I'll even do 47. So if you want to make a stab at 45, pause the video and give it a go. If not, I'll walk through you with it. So first step in this problem, get the left-hand side written as 1 logarithm, kind of using the minus to divide rule. When there's 2 logarithms that have the same base and they're separated by a subtraction, you can make the 2 logarithms into 1 logarithm by dividing their arguments. Next, I'm going to cross out the log. And when I cross out the log, I'm going to leave the 2 on the left-hand side. I'm going to leave the equals where it's at. I'm going to move the fraction over to the right-hand side. And this 2 is going to move to the left-hand side and become an exponent. So the left-hand side has a 2 squared, which is just 4. The right-hand side is x over x minus 6. I really like to solve these fraction problems with cross multiplying, so I'm going to set it up to cross multiply by writing the 4 as 4 over 1. Because now I have a perfect cross multiplying problem, so I'm going to cross multiply up and down. Doesn't matter which side you do the cross multiplying on. my one direction, I'm going to have 4 times x minus 6. The other direction, I'm going to have 1 times x. This is going to give me 4x minus 24 equals 1x. I'll minus 4x from both sides. That will give me minus 24 equals to minus 3x. And I'll divide both sides by minus 3. And that will give me 8 equal to x. And that's going to be my answer, I believe, but I'm going to check it. So I need to leave this off the screen now, so you start to lose that. So for checking, I'm going to plug 8 in for these x's and see if the log base 2 of 8 minus the log base 2 of 8 minus 6 equals to 2. And this 8 minus 6 I'm going to do as a 2 just because it makes it easier for me. So on my calculator now, check mode, I'm going to go log for the first one, log of 8 divided by the log of 2, minus the second one, I'm going to do log of 2 divided by log of 2. So log of 8 divided by log of 2 for this one, log of 2 divided by log of 2 for this one. Better give me 2 because the right-hand side is 2. And it does, so I feel great about that answer. So I'll move on and do the next few problems. I'll do both 47 and 48 on this page. Again, if you want to give 47 a crack because you think you can do it, that's a great idea. Pause the video and then fast forward through my work if you want to. I'll do 48 in a second here. 48's different because it has a plus between the logarithms. So to get started on 47, I'm going to rewrite the left-hand side with one logarithm. I'm going to write it as a log base 2 of x plus 6 over 3x plus 2 equals negative 1 because if you have two logarithms with the same base, separate it by a minus, you can make those two logarithms into one logarithm using the minus to divide rule. Cross out the log. Leave the 2 on the left-hand side, leave the equal sign where it's at, move the fraction over and leave it at the same level as the 2, make x plus 6 over 3x plus 2. Move the 1 over and make it an exponent. The left-hand side is 2 to the negative 1, which is 1 over 2 to the first, which is 1/2. So I can rewrite the left-hand side first with a fraction with an exponent of 1, and then with a just lovely fraction. So if I did 2 to the negative 1 on my calculator and did math enter, enter, I'd get that as equal to 1/2. So now I have the problem written so it has a fraction equal to a fraction. I'm going to cross multiply. When I cross multiply, it doesn't matter which way I go. I'm going to do 2 times x plus 6 on one of the sides and 1 times 3x plus 2 on the other side. This is going to give me 2x plus 12 equals 3x plus 2. Now I'm going to minus 2x from both sides. That's going to give me 12 equals to x plus 2. And then I'm going to minus 2 from both sides. And that's going to give me 10 equal to x. And I claim that that's my answer to problem 47. I should definitely check. And for checking, I need to go the log base 2 of 10 plus 6 minus the log base 2 of 3 times 10 plus 2, and that needs to be negative 1. When I go to do this on my calculator, the 10 plus 6 I'm going to write as 16. It's just going to make it easier on my calculator to do the logarithm like that. And this is going to be 3 times 10, which is 30, plus 2, which is 32. The second logarithm I'm going to do is a logarithm of base 2 of 32. And that should still equal to negative 1. So on my calculator for checking, first logarithm I do log of 16 divided by the log of 2. Then the minus sign. Second logarithm, log of 32 divided by the log of 2. When I hit enter, I best get minus 1 because that's what the right-hand side is. So that's perfectly checked, so my answer is in fact correct. The last 4 problems that we have are going to be harder because so the problem 48 that we've been staring at, I started solving it and realized that horrible things happen in that you need the quadratic formula to get the problem solved, and I certainly didn't want that to happen. So I'm going to change that problem to, trying to figure out what to make this equal to 5. I'm going to make a problem work a little bit easier. So I'm going to change that problem 48 just a little bit. I changed the x plus 2 to an x plus 4. I changed the 3 to a 5 for good purposes. So the few problems that we've just done have had 2 logarithms on the same side of the equation that we made to 1 logarithm, which I need to do again. This logarithm has a plus between it. So when I make the 2 logarithms into 1 logarithm, I'm not going to make a fraction. I'm actually going to multiply the arguments. When you have 2 logarithms separated by a plus sign, if those logarithms are the same base, you can make the 2 logarithms into 1 logarithm by multiplying the arguments. So to get started on our last 4 problems, this is our first step, is going to be to use the addition to multiplication rule. Now I'm going to clear and do the multiplication here by multiplying x times x and 4 times x, and that's going to give me the log base 2 of x squared plus 4x equals to 5. And now I'm going to get rid of the logarithm. On the left-hand side, I'm going to cross out the logarithm. I'm going to leave the 2 on the left-hand side. I'm going to leave the equal sign where it's at. The argument's going to move to the right-hand side. It won't need to be in a parentheses, and it's going to be on the same level as the 2. The 5 is going to move to the left-hand side and become an exponent. 2 to the 5th on the left-hand side, you can use your calculator, or you could just know that that's 32. So now I'm getting x squared plus 4x equals to 32. I'm not going to cross multiply because there's no fractions. And I have an equation that has a square. When you have an equation that has a square, probably the best thing to do is set it equal to 0 and solve by factoring. And that's what I'm going to do here. I'm going to set it equal to 0 and solve by factoring. This is supposed to be easy factoring. At least it's not bottoms-up factoring. It's going to factor into x plus 8 times x minus 4. Now that I have it set equal to 0 and factored, I'm going to set each of the factors equal to 0, and each one's going to give me an answer that I need to check. The first one's going to give me x equal to negative 8 for an answer. The second one's going to give me x equal to 4. The x equal to 4 is going to check. Let me show you how it checks real quickly, and then I'll worry about the negative 8. So for checking the x equal to 4, I'd go the log base 2 of 4 plus 4 plus the log base 2 of 4 equals to 5. When I enter this on my calculator, I'm going to make that an 8. And on my calculator, to check this, super easy, I'm going to go the log of 8 divided by the log of 2 plus the log of 4 divided by the log of 2. And that's going to give me 5 equal to 5, which is perfect. So x equal to 4 checks, and it's a solution. The next one, when I go to check it, when I plug negative 8 in for those, I'm going to go the log base 2 of negative 8 plus 4 plus the log base 2 of negative 8, and that's supposed to equal 5. When I go to enter this on my calculator, negative 8 plus 4 is negative 4. And we'll see what happens when I go to check this. So on my calculator for this one, I'm going to go log of negative 4 divided by the log of 2 plus log of negative 8 divided by the log of 2. And my answer is right if I see 5. And I see 5 plus 9.06 something with an I. That's not exclusively 5. That doesn't equal 5. It equals a number with an I. Logarithms of negative numbers turn into an I, because when I went to check this, I didn't get the beautiful perfect checking like the last one. This one's not a solution. We call it an extraneous solution. Extraneous meaning extra. It's an extra solution that the algebra produces that doesn't check. When I go to write my answer for this problem 48, I should not include the x equal to negative 8. The only answer should be the x equal to 4, because it's the only number that I can plug in to make both sides the same number. So that's 48. That's a bit tricky. Your problem 49 is just like my 48. When I look at problems 51 and 52, I'm worried that 51's a little bit harder than 50, should I say. So I'm going to do 51. You should pause the video and do 49, because that's just like this version of 48. It's going to work out the same way. But 51 I'm worried about, so let's do 51 instead of 50. You want to try 51 without me, that would be great. But if you don't, that's okay. So to start problem 51, I'm going to rewrite the left-hand side so that it only has one logarithm. And I can do that because both logs have the same base. They have a plus sign between, so I'm going to multiply the arguments. And I can rewrite the left-hand side as a log base 3 of x plus 6 times 3x. I'm going to do the multiplication that's implied here, which is x times 3x and 6 times 3x. That's going to give me the log base 3 of 3x squared plus 18x equals to 4. And now in problem 51, I'm going to cross out the log. I'm going to leave the 3 on the left-hand side. I'm going to leave the equal sign in place. I'm going to move that 3x squared plus 18x to the right side and leave it at the same level as the 3. I'm going to move the 4 to the left side and make it an exponent. 3 to the 4th is 81. So this is going to give me 81 equals 3x squared plus 18x. I'm going to minus 81 from both sides and get something that I don't want to factor, so I could use the quadratic formula if I care to. A nice thing about this problem is anytime you have a problem that has an equal sign and there's a common factor that doesn't have a letter, you can divide that common factor away. Each of the numbers in this version of the problem are divisible by 3. I can divide those by 3, and you can only do that when the initial problem has an equal sign, which this does. And this problem, 0 equal to x squared plus 6x minus 27 will have the same solution. 18 divided by 3 is 6. 81 divided by 3 is 27. I'm going to factor this and get 0 equals to x plus 9 times x minus 3. Then I'm going to set x plus 9 equal to 0 and get x equal to negative 9, and set x minus 3 equal to 0 and get x equal to 3. I should check both of these because the negative one's not going to work. So the first one I'm going to check is x equal to negative 9 by going in the original problem, do the log of base 3 of negative 9 plus 6 plus the log base 3 of 3 times negative 9, and that has to equal to exactly 4. I think it'll probably have a 4 with an I. So this on my calculator, let me just simplify this a little bit. This is a log base 3 of negative 3, because negative 9 plus 6 is negative 3. And this is a log base 3 of 3 times negative 9, which is negative 27. That's supposed to equal 4. So log base 3 of negative 3 plus log base 3 of negative 27 is supposed to equal to 4. On my calculator, if I do that, for this one I go log of negative 3 divided by the log of 3, and then plus log of negative 27 divided by the log of 3. And again, I get that I part. I get the 4, but then I get an I part. That doesn't check. So the x equal negative 9 is not a solution because when I plug it in, I don't get exactly the right-hand side. Now I'm going to check the x equal to 3 by plugging 3 in for these. I'm going to do the log base 3 of 3 plus 6, plugging a 3 in for that x, plus the log base 3 of 3 times 3, and that's supposed to equal 4. Just to make it easier on my calculator, this is the log base 3 of 9 plus the log base 3 of 9, and that's supposed to equal to 4 because 3 plus 6 is 9 and 3 times 3 is 9. Now I break out my calculator, and on my calculator I'm just going to enter that. I'm going to go log of 9 divided by log of 3 plus log of 9 divided by log of 3, and that gives me 4. Both sides come out to be 4, so this is the only solution. X equal to negative 9 is called an extraneous solution. It shouldn't be included in the answer. So for problem 51, the only answer that I should choose is the one that checks which is the x equal to 3. Alright, so I'm going to stop the video here, and we'll move on and have 3 sections left. I think they're all word problems, but not the worst word problems ever.